Deep Learning Debunked. Unraveling 5 Persistent Myths. Deep learning is a new technology that has only recently emerged. False deep learning, a subset of machine learning based on artificial neural networks, has roots dating back to the 1940s. The term deep learning gained traction in the late 2000s due to improved computing power and breakthroughs in algorithms. Educate yourself on the history of deep learning by reading seminal works like Perceptrons 1969 by Marvin Minsky and Seymour Papert, or Learning Representations by Backpropagation Through Time 1986 by Paul Werbos. Recognize that deep learning is a continuation of decades of research and development in artificial intelligence. The concept of neural networks can be traced back to Warren McCulloch and Walter Pitt's 1943 paper A Logical Calculus of the Ideas Immanent in Nervous Activity. Deep learning is not a novel technology, but an evolution from decades-old research. Deep learning is limited to image recognition and natural language processing. False. While deep learning has made significant strides in these areas, it has numerous applications across various domains, including finance, healthcare, autonomous vehicles, and music generation. Explore projects like Google's AlphaGo Zero, which uses deep learning to master complex games without human guidance, or DeepMind's protein folding project, aimed at solving one of the grand challenges in biology. Stay informed about recent advancements in deep learning by following reputable AI research organizations and publications, such as Google Research, OpenAI, and AR14. DeepMind developed a deep learning model called AlphaFold that can predict protein structures with unprecedented accuracy, revolutionizing the field of structural biology. Deep learning is versatile and has far-reaching applications beyond image recognition and natural language processing. Deep learning requires massive amounts of data to train models. Partially true, but misleading. While deep learning models can require vast amounts of data for optimal performance, recent advancements in techniques such as transfer learning and data augmentation reduce the reliance on large datasets. Learn about transfer learning by experimenting with pre-trained models provided by libraries like TensorFlow or PyTorch. Implement data augmentation strategies to artificially increase the size of your training dataset. Using transfer learning, a model can be fine-tuned on a specific task with only a few hundred examples, achieving results comparable to models trained on millions of images. Deep learning does not always require enormous datasets for effective modeling. Techniques like transfer learning and data augmentation can help reduce the data dependency. Deep learning will replace human jobs in vast numbers. Overly pessimistic. While automation and AI advancements may displace some jobs, they are also expected to create new opportunities for human workers. The integration of deep learning should be viewed as an opportunity for collaboration between machines and humans rather than a threat. Cultivate skills that complement AI systems, such as critical thinking, creativity, and emotional intelligence. Advocate for responsible AI development and implementation to minimize negative societal impacts. In the field of healthcare, AI is used to assist doctors with diagnostics, enabling them to provide more accurate and timely care for their patients. Deep learning will not eliminate human jobs but can augment human capabilities, creating a symbiotic relationship between machines and humans. Deep learning models are always infallible and unbiased. False deep learning models learn from the data they are trained on, which may contain biases. Or in Deep Learning Debunked, Unraveling 5 Persistent Myths. Why it matters. Understanding the truth behind these myths is crucial for anyone interested in artificial intelligence and deep learning. as misconceptions can lead to misunderstandings about the capabilities and limitations of these technologies. This knowledge empowers individuals to make informed decisions, develop innovative solutions, and contribute positively to the AI community. Table of Contents 1. Myth 1-2. Myth 2-3. Myth 3-4. Myth 4-5. Myth 5-6. Myth 6-7. Myth 7-8. Mini Case Study 9. Common Misconceptions 10. What Changed 11. Actionable Playbook 12. Recap 13. FAQ 14. CTA All deep learning algorithms are complex and require advanced mathematical knowledge. Partially true, but misleading. While some deep learning algorithms can be mathematically complex, there are also simpler models that are easier to understand and implement. It's essential to choose the appropriate model based on the problem at hand, rather than being intimidated by the perceived complexity of deep learning as a whole. Familiarize yourself with various deep learning models, such as linear regression, logistic regression, and support vector machines, which require less advanced mathematical knowledge. Explore user-friendly platforms like TensorFlow Playground or Keras for an intuitive introduction to deep learning concepts. The Lenet 5 convolutional neural network, introduced in 1998, is a simple yet powerful model that has been used successfully in image recognition tasks. Deep learning is not exclusively complex. Various models cater to different levels of mathematical expertise and problem domains. Deep learning is only useful for large companies with significant resources. False. With the availability of open-source libraries like TensorFlow, PyTorch, and Keras, deep learning can be accessible to individuals and small organizations as well. The key is to focus on problem solving and innovation rather than the scale or resources at your disposal. Leverage open-source tools to build and train deep learning models without requiring extensive computational resources. Participate in online communities, forums, and competitions.